Today we're going to learn how to apply the Pythagorean theorem to solve real-world problems. You should be on page 28 in your notes packet. Question 1 says the bottom of a ladder must be placed 3 feet from a wall. The ladder is 12 feet long, so how far above the ground does the ladder touch the wall? The best way to think about this is to actually draw a picture so that you can see what this looks like. So if we have a house, and it's just a simple sketch. So if we have a house and we have a ladder that is resting against a wall, then it would look something like this. Well, then you have to figure out what these measurements are. It says the ladder must be placed 3 feet from a wall. So this is the bottom of the ladder, 3 feet from the wall. Well, here's the bottom of the ladder and here's the wall. So that means that the distance from here to here is going to be 3 feet. Then it says that the ladder is 12 feet long. So that is the length of the ladder, which is this part. The question asks, how far above the ground does the ladder touch the wall? Well, here's where the ladder touches the wall, and we want to know how far above the ground that is. So we're looking for the distance from here to here. Well, whenever you have a wall, unless otherwise stated, the wall and the ground should always create a right angle. Because of this, we can use this, and we know that what we've created here is technically a right triangle, and we can apply the Pythagorean theorem to this. So we would use our formula a squared plus b squared equals c squared. In this case, we would be missing one of our legs. Our other leg has a measurement of 3, and our hypotenuse has a measurement of 12. So we're going to plug that into our formula, and we're going to use 3 for A. We don't know our other leg, so we're leaving B. And we know that our hypotenuse is 12, so we're going to plug that in for C. Well, then we just solve. So 3 to the second power is 9, plus B to the second power, and then 12 to the second power is 144. Well, we need to get B by itself, and what we're doing here is really just solving an equation. So to get B by itself, we need to first get rid of this 9. So to get rid of 9, we're going to use the inverse operation, which is subtracting 9 from both sides of our equation. Well, when we subtract 9 from both sides of our equation, we're left with B squared here, and then we're going to subtract 144 minus 9. When we subtract 144 minus 9, we get 135. Well, remember, B is still not by itself at this point. B still has an exponent with it. So in order to get B by itself, we would need to do the inverse of an exponent of 2, which is taking the square root of both sides. The square root of B squared is B, and then the square root of 135, since we know that 135 is an irrational number or not a perfect square, we know that it's going to be an irrational number. So for this, we're going to approximate it to about the nearest tenths. Well, when we round this to the nearest tenths and put it in our calculator, we're going to get approximately 11.6. So the ladder is approximately 11.6 feet above the ground. Number 2 says John leaves school to go home. He walks 6 blocks north and 8 blocks west. How far is John from school? Well, again, draw out the situation. So if John starts right here at school, we know that he walks 6 blocks north. So that means that he's going up because north is going up, and that is 6 blocks. Well, from here, he walks 8 blocks west. So he turns immediately and walks west 8 blocks. Well, if we go from north and directly to west, then that is actually creating a 90-degree angle. The question asks, so at this point, John is right here, but it asks how far he is from school. Well, technically, he could go back 8 blocks and then another 6 blocks, but really, the shortest distance between 2 points is a straight line. So really, we want to know how far away is this point from this point. So what we've done again is created another right triangle, and what we're missing is the hypotenuse, which would tell us the distance from where John is now to the school. Well, we know both of our legs, so when we have our formula a squared plus b squared equals c squared, we're going to plug in 8 and 6 for our legs, but we know that we're missing our hypotenuse. Well, 8 squared is 64 and 6 squared is 36, and again we're missing c squared. When we add 64 plus 36, we get 100. So our equation says 100 equals c squared. Again, c is not by itself yet. You do not have an answer at this point because c still has an exponent of 2. So you're going to have to use the inverse of that, which is finding the square root of both sides of this equation. The square root of 100 is 10, so we have a solution that says 10 equals c. That means that John is 10 blocks from school. Number 3 says televisions are measured by their diagonals. If Mary purchases a portable television that measures 10 inches long and 15 inches wide, what is the length of its diagonal? Well, you have to think about what this means. So if we have a TV, the diagonal is this piece that runs diagonally in between the TV. But Mary has one that measures 10 inches long and 15 inches wide. So we know the length and the width of this TV, but what we don't know is the measure of the diagonal. Well, again, if this was made correctly, it should have a 90-degree angle here, which means that what we would be missing would be our hypotenuse. So we would plug into our formula a squared plus b squared equals c squared. We're going to use 10 and 15 for a and b, and we're looking for c. Well, 10 to the second power is 100, and 15 to the second power is 225. When I add 100 plus 225, I get 325. Well, then I need to get c by itself, so I'm going to need to take the square root of both sides of this equation. So when I take the square root of 325, I'm going to get approximately, and you'll notice something strange with this, you're going to get approximately 18.027, and it continues on. But if we rounded this to the nearest tenths place, the tenths place is this 0, and the 2 tells us what to do with that 0. Because that 2 is below 5, it tells us we're not rounding that 0 up. So really, this is 18.0. Well, I don't need to say 0.0 because if something is 0.0, then it's really about 18. So the square root of 325, although it is not exactly 18, we're going to say that it is approximately 18. So for this, the length of the diagonal is approximately 18 inches. So that means that they would say that this TV measures 18 inches since TVs are measured by their diagonals. Number 4, two sides of a right triangle are 8 inches and 12 inches. Find the missing side if these are the lengths of the legs. So if 8 inches and 12 inches are the lengths of the legs, then when I plugged that in and I drew a triangle, 8 and 12 would be here. And I would be missing a hypotenuse. So if I plugged that into my formula, a squared plus b squared equals c squared, I would know that I would use 8 and 12 for a and b since those are my legs. Well, 8 squared is 64 and 12 squared is 144. And I would add 64 plus 144, which would give me 208. Well, then I would just need to find the value of c, so I would take the square root of both sides. When I find the square root of 208, I get approximately 14.4. So that means that c would be approximately 14.4. Now, when you look at part B, it says find the missing side if these are the lengths of a leg and the hypotenuse. So for part A, we were assuming that 8 and 12 were both the legs. But for part B, we're assuming one is a leg but the other is the hypotenuse. Well, when I'm sketching this on a triangle, I need to know which one of those I would use as the hypotenuse. Well, we know that the hypotenuse is always the longest side of the triangle. So if 8 and 12 is one of these is a leg and one of these is a hypotenuse, then I know 12 would be the hypotenuse because that's the longer side length. So that means 8 would be a leg, and what I don't know is what one of the other legs measures. So when I plug this into my formula, I'm using 8 for a leg, but I don't know the other leg, and I'm using 12 for my hypotenuse. So again, 8 squared is 64, and 12 squared is 144, but for this step, I actually have to subtract 64 from both sides so that I can get b by itself. Our 64s will cancel to leave us with b squared equals, and 144 minus 64 gives us 80. To get b by itself, we're going to find the square root of both sides, which will leave us with b. And since 80 is not a perfect square, we're going to say that this is approximately. And when we find the square root of 80 and round it to the nearest tenths place, we're going to get approximately 8.9. So for this, if this was the measure of a leg and a hypotenuse, then the other leg would measure approximately 8.9 inches. Number 5, the foot of a ladder is placed 6 feet from a wall. If the top of the ladder rests 8 feet up on the wall, how long is the ladder? So again, draw a picture so that you can see this. So if you have a house, you have a ladder, and it says the foot of a ladder is placed 6 feet from a wall. Well, the foot of the ladder is the bottom of the ladder, so it's placed 6 feet from the wall, which means that's what this measurement is. Then the top of the ladder, so here's the top, rests 8 feet up on the wall. So that's this measurement. So that means we're looking for how long is the ladder, which is this part right here. Well, again, this would be your hypotenuse that you would be looking for. So if I did a squared plus b squared equals c squared, my legs would be 6 and 8. So I would plug those in for a and b, and I'm looking for c. Well, 6 squared is 36, and 8 squared is 64. And when I add 36 plus 64, I get 100. So again, to get c by itself, I need to find the square root of both sides. And the square root of 100 is 10. The square root of c squared is c. So that means the ladder is 10 feet long. Number 6, Destiny leaves work to go home. So right now we know that Destiny is at work, but she walks 12 blocks south, so she's going down 12 blocks, and then 5 blocks east, so she's going east 5 blocks. How far is she from work? Well, if she's here right now, then we know that to get to work, she could just do a straight line. So really, if this were a right triangle, we would be missing the hypotenuse. So since we know legs, we're going to plug that into our formula for A and B. So we're going to plug in 12 and 25 and then solve. Well, 12 squared is 144, or not 25, I'm sorry, 5 squared, and 5 squared is 25. When we add 144 plus 25, we're going to get 169 equals c squared. Well, again, to get c by itself, we're going to have to take the square root of both sides, and the square root of 169 is 13. So that means Destiny is 13 blocks from work. Now for number 7, you see that you have a cone. The first thing I want you to do is go back up to the top of your page where it has the formula for the volume of a cone. It's actually missing one piece. So it is 1/3 times radius, or times pi times radius squared, but there also should be an h there to represent height. So everybody add an h to your volume to represent height. Now we're going to use this to find the volume of the cone. We need to look at the information that this gives us. It says that the cone has a diameter of 10 centimeters. Well, remember, diameter is the total length across. But for a volume of a cone, I actually need the radius. So if the diameter, the whole distance across, is 10, then the radius is only half of that. So that means that the radius is 5 centimeters. So I'm going to draw that on my cone so that I can see it. Then it says that our cone has a slant height of 13 centimeters. A slant height is different than an actual height of a cone. Remember, we have talked about in geometry when you have a base and a height of a figure, that those measurements are always found from a right angle. If we have a slant height, the slant height is the measurement of this slant or this incline right here. So our slant height would be 13, but that's not the actual height of the cone. The actual height of the cone is right here. So we've got to do a little bit of work to find the height of the cone. What we see here is that with this height and this radius, we create a right triangle along with this slant height. So we can actually use this information to find the height of the cone. What we have is a leg of 5 and a hypotenuse of 13. So we would be missing one of our legs. So if I plug that in my formula, I'd have a leg of 5, but I don't know my other leg. And then I'd have a hypotenuse of 13. And then I can solve. Well, 5 squared is 25. And then 13 squared is 169. To get b by itself, I would need to subtract 25 from both sides. My 25s would cancel to leave me with b squared equals, and then 169 minus 25 is 144. Well, now to get b by itself, I'm going to find the square root of both sides, and the square root of b squared is b. The square root of 144 is 12. That means that the height here is actually 12. Now I can use this information to plug into my formula for the volume of a cone. So that formula is volume equals 1/3 times pi times radius squared times height. Well, remember, multiplying by 1/3 is the same as dividing by 3, so you can multiply all of this, then divide by 3. Well, pi is 3.14. Well, that's not really what pi is, but that's the approximation that we use. Our radius is 5, so we've got to do 5 squared. And then we found that our height was 12. Remember, you cannot use slant height. You have to use actual height that comes from a right angle. Well, then we're just plugging all of this into our calculator. So we know that, first of all, our 5 squared is 25. And what we can do is multiply 3.14 times 25 times 12. And you can multiply that by 1/3, or you can multiply all these together and then divide the answer by 3. Either way, you should get the same answer. So we're going to get an answer of 314. Now remember that volume is always measured in cubic units. So since these were centimeters, we're going to say that it is centimeters cubed. So the volume here is 314 centimeters cubed. For number 8, we're going to do the same thing, and we're going to use our formula 1/3 times pi times radius squared times height. Well, this one says that we have a height of 24. Well, height is this measurement right here, so our height is 24. And it says we have a slant height of 25. Well, the slant height is this slant right here, so this is 25. Well, it wants us to find the volume, but to find the volume, we need the radius. So we need this measurement right here. Well, that means that we are missing a leg here. So we're going to have to solve this and find the missing length. When we plug into our formula, we know that we have one leg that measures 24, but we don't know the measurement of the second leg. We know that we have a hypotenuse over here that measures 25. Well, then we're going to just solve this. We've got to do 24 squared, which gives us 576. Then plus b squared. And then we have to do 25 squared, which gives us 625. Now to solve this, we have to get b by itself. So the first thing we need to do is subtract 576 from both sides of our equation. Well, our 576's will cancel to leave us with b squared equals, and then 625 minus 576 gives us 49. To get b by itself, we need to get rid of this exponent. That means we need to find the square root of both sides of this equation. That leaves us with b equals, and then the square root of 49 is 7. So that means that the radius here is 7. We already knew that the height was 24, and now we can use all of that to find the volume. So remember, we're using v equals 1/3 times pi times radius squared times height. Well, that's 1/3 times 3.14. Our radius is 7, so times 7 squared, and then our height is 24. Well, we know we need to find 7 squared first, so 7 squared is 7 times 7, which gives us 49. And now all we have to do is multiply all of this straight across. When we multiply all of this, we get 1,230.88, and because it's meters, we know that we're going to write this as meters cubed. So our volume here is 1,230.88 cubic meters.